This problem right here is a little bit more complicated because it's asking for where it's concave down and decreasing. It's bringing two concepts together. Concavity is a second derivative, decreasing is a first derivative. So here we go. What we have to do is take our first derivative to get decreasing. So we take the derivative of this, here it is. Then you have to set the first derivative equal to 0 to find critical numbers, to find the breaks where decreasing might happen. So I pull out my GCF of 3x, set each factor equal to 0, solve them, and I get 0 and -4. Those are my two breakpoints. And then what I'm going to do is that for concavity, I'm going to find my points of inflections and intervals for concavity. So I take the derivative of this, which would be the second derivative. There it is. You set the second derivative equal to 0. When I solve that, that's my possible point of inflection. See, minus 12 over divided by 6, that's a possible point of inflection. So what I didn't do is make my little table for my first derivative, make my little table for my second derivative, and kind of line them up. Okay, remember this is a possible point of inflection at -2, -4 and 0 are my critical numbers, possible interval increasing, decreasing changes. And so then what I do for my first derivative is I plugged in numbers on the interval. So -5 gave us a positive, which means this is increasing. -1, which is on this interval, give us a negative. So for this whole interval, it's decreasing, which we're asking for. And then if I plug in something from this interval, like 1, I got a positive, so this is increasing. So right away, I know between this -4 and 0, I'm decreasing. So I'm going to focus in right here, because that's what it's asking for. Now I want to find concave down. So for my second derivative, I plug a value on either side of -2. As you can see, I plug in -3 and -1. And when you do that, you plug in the second derivative again. I got a negative. When I plug this into my second derivative, I get a positive. So if I'm saying concave down, isn't it this interval? All right. So remember, when you're plugging in here, make sure you plug into the first derivative. Here you plug in second derivative, because this is for increasing, decreasing, this is for concavity. The question is where they're both concave down and decreasing. So if you look at this, can you tell right here on this interval, aren't we decreasing and concave down? For this interval, we're increasing and concave down. For this interval, we're decreasing and concave up. Here we're increasing and concave up. So you could find different things according to what the question's asking. Since this one's asking for that interval from the information, we can tell my interval for concave down and decreasing is from -4 to -2. I like this problem. Just make sure, hope you do, just make sure you get both derivatives, you check for critical numbers, check for point of inflections, line them up nicely, and see where the overlap happens. And just make sure you read the question carefully and don't make a little dumb mistake. I hate those dumb mistakes. You're like, oh, I missed that, I didn't read that. So be careful.